Hello, this isn't a tutorial. I just decided to open Revit and have a play around with making timber frames. I don't normally do things the way other people do. I just explore my own way and make things my own way. And this is just a casual video. I'm not teaching anything. I'm just playing with timber frames, and you can feel free to watch if you want, and that's what I recorded it for. You don't have to watch this video. I'm just gonna be talking whatever comes to my mind. So I'll get started with doing a timber frame. I was studying timber frames to see how they're different from steel framing. There's not much difference, it's just in the connections, the way they're connected. As with steel framing, you have the way they connect is they slot over each other, and timber frames fix to each other. How they fix to each other exactly, I have an idea, but I'm not exactly sure how, so I need to find that out. Maybe they're just nailed together. I know that trusses are fixed together with those square metal things. Those thin square metal things that have spikes in them, and what are they called? You just hammer them into the corners and it holds both sides together. Alright, so where's the insert? There is an easy way to do all this. There's an easy way to make timber framing, but I never do it the easy way. I always do it the hard way, because I like to understand Revit inside out, and I find that when you do it the hard way, you can recruit a lot of tools to help you make a timber frame. It's like you're using each tool, you're using your understanding of the tools to try and form something. So that's what I'm gonna do. Now the timber member sizes for a timber framed wall, from what I know, are dimensioned 50 millimeters by 100 millimeters. I'm not sure what that is in American inches and feet. I'll just load this one in, and then I'll edit it. Okay, so structure, beam, or column actually, whatever. Right, edit, duplicate, 50 by 100. So one has to be 50 and one is 100, and I'm not sure if that's the right way around. Let's find out. That's not the way that I want it to be. It has to... Well, we could do this. Change that to 90 and it'll do that. But I'd rather change it this way, just to prevent any potential problems that might happen. And problems will happen because this is Revit. Revit is known for causing headaches, frustrations. Let's see, view range. So this is unlimited. Oops, unlimited. And that's how you get that to show. Okay, so there's our bottom track and top track. Now I'm gonna insert a column. Load the same sort of thing. Do the same thing again. I tried to load a structural framing when I should have loaded a structural column. Yeah. Go back to structural columns. Wood, timber. If it's incompatible, why is it working then? Revit, Revit, Revit. Sometimes I hate you. Sometimes you make me want to attack my computer. Alright, where's the load family? Yeah, we'll just grab anything here. I wanna grab it. Okay, I have an idea. Let's just load this in instead. What are you doing? You just never let things happen straightforward, do you? An incompatible version of family timber is already in use in this project. Cannot load. Okay. Maybe it's already loaded. Revit, stop messing around, man. Just do what I want you to do. I don't have time to play games. And the people watching this, if they made it this far, they don't have time to watch you play games either. Just do what you're told. Alright, now I can't select anything. Right, let's do this calmly. I can do another thing, but I don't like doing it. Alright. I'll just use this. I prefer it to be the same as this, but if you want to mess around, you can. You know what? Another solution to this could be to just save the timber family as timber 2. So you have timber and timber 2, and then maybe that'll work as a structural column. I'm not gonna waste my time. Oh, this almost fits. Okay, so I need this to fit within this, so edit type, duplicate 50 by 100. And I think this one's a bit straightforward, so 50 by 100. I'm gonna align it to this. Now, I don't want that to be happening, because this is a top track or a bottom track. It should be that this is going over the top of that and resting on top of it, not like that. And with Revit we can do a number of things. And let's see if we can play with this. So normally the height of a wall is 2676. That's what I normally see. Okay. Oops. What did I do? 2. Actually, the top level should be level. Top level should be level 1, and the bottom level should be 0. Okay. And then we'll extend this over. That's it. That's what I want. Right, now these studs, they have to be 400 millimeter centers to 600 millimeter centers. So I'll copy this over by 600. Alright, 1 sec, I'm just gonna, where's the elevation? Just gonna change this to 2676. Okay. Right. So the distance between these two should be 600 or 400. The reason for that, you'll find out in a more detailed video when I'm actually framing that Revit model that we did before. So we're working on a timber frame house model, and I have to put a timber frame inside the model, which we've sort of completed the external facade of. Okay, so this should be 1800 wide. 1850. Centers, I guess, means from center to center. Yeah, should be alright. Hold on, I'll do it like this. So move this stud over and move this stud over and move this stud over. That's it. And that's what it's supposed to be. And then this can be brought back to here. Is that? Trim that back as well. Alright, let's check it one more time. It should be 1800. There it is. And this can be copied up. Let's see if you, of course it can't be copied up. Okay. So I'm just holding control on the keyboard and dragging it around. And then, so there's two here now. And I need to take the one that's newly created and put its Z offset value. Let's put it at 2676. So let's see what that distance has to be. 50. 2726. And trim it over. So the height of the stud actually should be from, oh, I can't dimension this. Medium. So the height of this whole panel should be 2676. not. So this has to drop down 2676 by 100. 2626 2676. The height of this can be whatever you want. I'm just doing it to a normal room. Drop these by 100. The top offset should be minus 100. And there we go, we have a timber frame. Now normally on a steel timber frame you have a bracing strap going from corner to corner to stop this thing from bending. And also noggins as well. So let's put a noggin in. What's a noggin, you ask? You're about to find out. Z offset 1200. So a noggin is for reinforcement of the frame and also for hanging stuff on. So you can have a cupboard and the cupboard can fix to the noggin. Alright, so that's our noggin. Now we need some sort of strap. What sort of straps do they have in real life? Let me have a quick look. So apparently we have some sort of timber strap that goes from corner to corner, and that's only fixed for when delivering these to the construction site so that they don't bend out of shape. And once they're installed on the construction site, then you take them off. And I wonder if there's some other kind of strapping. Like for example, I've seen when noggins are placed like this. So take one. Move it up, and the noggins are staggered like this. Chop this in half with my karate chop tool. So you see noggins staggered like this. Maybe this is enough to reinforce it. I'm not sure what kind of horizontal brace they would have for a timber frame, so that's something I need to look into. There's a timber frame. Now what if we put a window in this? Now how would a window look? Well, it's quite simple. Let's copy this whole thing over. Window or door? Let's do a door first. Height of a door 2110. So normal height of a door. Sounds about right. So I'm splitting this to help create a doorway. And this can go up. Let's add 2102. That's the height of a doorway. And the door thickness 910. 1010, let's make it 1010. creating a center line and dimensioning these to the center line. I'll lock this one down with a pin. Click this, half 10 10. Right, now this has to go back here, and this has to go back here, and let's see, how is this fixed now? Yes. So this carries on going all the way to the top. And the structural load can travel down the stud to the ground. Fixed like this, and we can put one in the middle. And the bottom offset has to be 2 1 6 Fine, 2 1 1 0. Alright, it's that how the doorway is supposed to be. I have a book for reference. So this part fits into the studs as a mortise tenon joint, like this, according to the reference in a book I have here. Yeah, that's about right for a doorway. We can get rid of all this mess. I'll keep it, it's not hurting anyone. Let's do a window. Window's the same thing. Okay, so we'll drop this down by, I don't know, 1,200. Let's drop it down lower. 450. Too low. Who cares? Right. Delete this. So this is going all the way to the end, and so is this going right up to there. Yeah. Now we're gonna copy a few of these in. For support, one here. Alright, we'll edit this and then copy that one. So the height for this is minus 2,000. Minus 2,276. Right. You can see where I'm going with this. that's being supported from both sides. And we'll drop one in the middle. Extra support. They should be 600 centers. That's fine. Okay. It's a window. Okay, that's a basic play with timber framing. So this is the sort of thing we're going to be putting into that model we were doing. And we're going to put these all around and create a timber framed wall. And these two go together, the studs go back to back. Let's go back to back here. And also for things like this door. So since these are prefabricated in the factory, maybe in our architectural model we don't need to, but if you're manufacturing it, you put one temporary track, this, put a temporary one down here for reinforcement, and it's labeled as temporary, and then when it gets to the construction site they take it off. It's for reinforcement. Yeah, that didn't turn out too bad. Alright, I think that tutorial is gonna be easy to make. You probably could do it yourself now after watching this. Alright.